Hello and welcome to part 3 of our series on how to make an operating system. Today we are just discussing some of the most common 16-bit assembly instructions, and we're most likely not going to have time to go through all of them, so we will continue discussing these in future episodes. So probably the most common assembly instruction that we're going to use is MOV. M-O-V. Okay. So, first of all, these assembly instructions are called mnemonics because in theory they should be easy to remember. So MOV stands for move. And this simply copies a piece of data from one location to another. And its syntax is MOV, then you have a destination, comma, and a source. So MOV, destination, source. The source can be either a CPU register, a memory location, or an immediate. Now, what an immediate is basically a value that you specify directly. So, for instance, you can do MOV, let's say AX. We move into the register AX, an immediate value OX50. So, we move this hexadecimal byte into the AX register. If the destination is a memory location, the source must either be an immediate or a register. That is, you can't directly copy data from one location of memory to another using the MOV instruction. So, if you do want to copy one word, let's say, from a memory location to another, you would first have to copy that word from the source into a register. So you do MOV AX, and then let's say you have a label on that memory location and the label is test. So you're copying one word from this memory location into AX, and now that you have the contents of this variable into the AX register, you can simply move it to your destination memory location. So let's say you want to move it to a memory location labeled var, and you're moving the contents of AX. So you need to do it in 2 steps if you need to copy from one memory location to another here. Okay, so that's MOV for you. It's pretty basic. Obviously, here, if you're copying 1 byte into AX, then AX here will be 0050 in hex. AX has 2 bytes. It's a word register. But you can copy a word into it as well. So MOV AX 0xFF30, let's say, and that will completely fill the AX register here. Or you can copy 1 byte into either AH or AL. So if you do MOV AH 0x23, and then you do MOV AL 0x33, then AX will be 0x2333, right? Because as you might remember from last time, AX is basically AH followed by AL. So these 2 registers are basically accessing 1 single byte within the AX register. So that's it on the mov instruction. Let's see some other instructions. Inc destination and dec destination. These two instructions are used to increment or decrement the contents of a register or memory location. So for instance, let's say I do mov AX 0 and then I do inc AX. Then the contents of AX will be 1. So it increments the value of AX, meaning it adds 1 to its value. Then if let's say I mov AX 50 in decimal, then I can do dec AX and AX becomes 49. So this decrements the contents of the AX register. And as I said, you can use either a register or a memory location, so you can increment some variable here or decrement it. And let's also take a look at add and sub today. So let's do them separately. The syntax for add is add destination source. And what this does is basically this: destination becomes destination plus source. So it computes the sum of these two values here and sets the contents of the destination to that value. So it just adds two numbers together. Like with mov, memory-to-memory operations are not allowed. So if you use a memory location for source, then you can't also use a memory location for the destination. You have to do it using a register and then move that register's contents to your final destination memory location. Sub has the same syntax, so sub dest source, and what this does is this: dest becomes dest minus source. And it basically behaves the same way as add. It has the same restriction, so you cannot do memory to memory subtraction. In the case of inc, dec, add, and sub, the CPU also sets some flags into the flags register, but we're not going to be worrying about that right now. When the time comes, we'll also discuss what happens there. So I think that's it for today. Next time we will discuss multiplication and division. Hope you enjoyed this and see you soon.